We're going to find the unit tangent vector and the unit normal vector, t of t and n of t, for the curve given by r of t, the vector function, is equal to t squared sine of t minus t times the cosine of t plus t times the sine of t. After we do that, we're going to use the formula kappa of t is equal to the magnitude of t prime of t divided by the magnitude of r prime of t to find the curvature. We'll recall that t of t is equal to r prime of t divided by the magnitude of r prime of t, and n of t is equal to t prime of t divided by the magnitude of t prime of t. I forgot to mention that for our curve, t is greater than or equal to 0. You have the pieces that you need, you have the skills that you need. I'd like you to go ahead and pause the video, come up with the unit tangent vector and the unit normal vector. Come back when you're done. How did we do? R prime is going to be 2t, the cosine of t, and then product rule for negative t times the cosine of t is going to give us negative cosine of t plus t times the sine of t. Of course, those cosine of t's are going to subtract out. For the third component, the cosine of t differentiates to the negative sine of t, and then we have the product rule again. So plus the sine of t plus t times the cosine of t. Again, the sine of t's subtract out. So r prime of t, we're left with 2t, t times the sine of t, t times the cosine of t. The magnitude of r prime of t is then going to be t times the square root of 5. This is where it comes into play that t is greater than or equal to 0. We don't need the absolute value. It is bad form to write a vector like ABC divided by some number d. We do not do that. Please, please, please. If you need to divide by something, then multiply it by its reciprocal out in front of the vector, because scalar multiplication is defined, but vector division is not. Since the magnitude of r prime is t times the square root of 5, and all of our components have a factor of t, the t's divide out, so the unit tangent vector t of t is equal to 1 over the square root of 5 times the vector 2 sine of t cosine of t. That is a sufficient form of the final answer. You could distribute the 1 over square root of 5 if you wanted to. I just chose not to. For the unit normal vector, we're looking at t prime divided by the magnitude of t prime. T prime is going to have 1 over the square root of 5 out front, and then 2 differentiates to 0, sine differentiates to cosine, and cosine differentiates to negative sine. The magnitude of this vector is going to be 1 over the square root of 5. Dividing that out gives us that n of t is equal to 0 cosine of t negative sine of t. It's clearly a unit vector, and you can double check to see that the vector t is also a unit vector. Now folks, all that was part A. For part B, we're going to use that kappa is equal to the magnitude of t prime of t divided by the magnitude of r prime of t to find the curvature. I'd like for you to pause the video, work on that, and come back when you're done with it. Since the magnitude of r prime of t is equal to t times the square root of 5, and the magnitude of t prime of t is equal to 1 over square root of 5 from part A, kappa of t is equal to 1 over the square root of 5 divided by t times the square root of 5. Simplifying that gives us that kappa of t is equal to 1 over 5t. This was a good choice of formulas to use given the tools that we had developed up to this point.